From doing the Boyle's Law lab, you should have come up with the relationship that P times V equals K, and this is known as Boyle's Law. And what K is a constant. So if it's a constant value, we should be able to use this relationship to come up with another scenario. So from your data, you might have had something that like 55 kPa gave you a, I should say a volume of 20 milliliters gave you a pressure of 55 kPa. So some of the questions asked you to predict what the volume would be, or the pressure would be at a new volume. So this would be something that you could solve as a proportion. So some of you probably did that for your lab. And if you multiply these two, you would get a K of 1100. So if we had a new situation, we could use that K value to solve for it. So if I know that P times V equals K, and I have a new volume of 30 milliliters, and I don't know what this is, I could work backwards and do 1100 divided by 30 and come up with a pressure. So this would be our unknown pressure. P would be equal to 37 kPa. Now you'll notice that this is the same, so we can rewrite Boyle's Law in a more simplified view, and this is often used for when you're changing conditions in experimentation. So since the K's are equal, another way that you could write Boyle's Law is P1V1 equals P2V2. And what this is telling us is this is condition 1. And the second set would be condition 2. So what we're going to do is solve that same question, or same problem that we did before. So we had 55 kPa times 20 milliliters, and we want to know what our new pressure is at 30 milliliters. So this just cuts out the middleman. So since the K's are equal, we can set the two conditions equal to each other as long as all of the other conditions are the same. So temperature and amount of gas has to stay the same, and we'll deal with those situations. And it's just a short little algebra problem from there. Okay, your units cancel, and you get a pressure of 37 kPa directly. So it's a pretty easy plug and chug equation. You may want to pause the video while you get out your mole flower. On the back side of your mole flower is a gas laws organizer. I'm doing this on the iPad, so I'm sorry that it looks a little different than what you're seeing, but we're going to focus in on just the Boyle's Law portion of this. And I'm just going to try to make this bigger. So what you're going to see for Boyle's Law then is that P1V1 equals P2V2. And if you need to stop the video so you can catch up with this, that's fine. Just pause it to get this. So what's held constant is the amount of gas and the temperature. And this one deals with two conditions. As you can see, there's many more gas laws coming your way, so this is to help keep all of them straight. So we're going to do some problem solving next. Okay, you will need a copy of the Boyle's Law worksheet, and just going to remind you of a couple things. You want to show your work, to follow sig figs, and be really mindful of units as you do these. So the Boyle's Law is at the top of the worksheet here, the P1V1 equals P2V2. Oftentimes what I have students do is when you start reading through a problem, a sample of oxygen gas occupies a volume of 250 milliliters. I'm going to go ahead and label that 250 milliliters V1. Remember that this little period here means 3 sig figs for that, and 3 sig figs here for the pressure of 740 torr. So again, that tells you it's pressure, so I'm going to label that P1. And it wants to know what volume will it occupy. So that's what we don't know, which is going to be my V2. it will occupy at 800 torr pressure. So this is P2. So I'm just going to plug my numbers in. Okay, and I just rearranged this. So whether you have a P1, V1, or P2, or excuse me, V1, P1, it's the same. They just happen to be in the order the volume was given first. So I'm going to do 250 milliliters times my 740 torr equals my V2, which is what I don't know, and my P of 800 torr. So again, remember, because of the commutative property, order does not really matter. Again, some very simple algebra. Divide by 800. All of these are to 3 sig figs, and that should give you a volume of 231 milliliters. I know this worksheet doesn't give you a lot of space to do the work, so you may want to just do the work on a separate piece of paper, and then you could use these for practice problems when we get to a test or quiz as well. For the next problem, I'm going to skip to question 7. And question 7 has similar things. I'm going to read my question. Chlorine gas occupies a volume of 1.2 liters. So that's going to be my V1. A pressure of 720 torr. So that's going to be my P1. Volume 2 is what I don't know again. And it occupies a pressure of 1 atm. So this is P2. So this is the one thing that you have to be careful of that can trip you up in these questions, is if your units don't match. So volume units have to match, pressure units have to match. So you just want to make sure that you're mindful of units. So we're going to build in the conversion. So what you're going to need for this is the idea that 760 torr equals 1 atm. Okay. So I'm going to build my bridge problem into my equation P1V1 equals P2V2. And if you kind of pay attention, this is what I'm going to need to solve. So I'm going to be dividing P2 on the other side of the equation. So since this is the one that's going to move, I'm going to do my conversion on this side. It really doesn't matter, but it does make your math a little easier if you start here. Okay, so I'm going to put my 720 torr in as my pressure. And I'm going to do a little bridge right here, and these are all really short, so 760 torr is 1 atm. I'm going to do all of that together times my volume of 1.2 liters equals my second volume. Let me do this. We'll do our pressure next. Equals our second pressure, which is 1 atm. And if you look back here, my torrs cancel, so I'm matching my pressure unit. And putting my V2 in. Now, again, with this being 1 atm, it's pretty easy to do that, but I just want to model that. There are other questions that are a little bit tougher than that, but and really, because this is only given to 1 sig fig, that gives you a volume of 1 liter just to 1 sig fig. So see what you can do with this. There's 6 other sample problems on there, and again, most of these are just kind of plug-in problems. So happy solving Boyle's Law problems.